In this video, we will be practicing stoichiometry conversions and how to calculate the percent yield, theoretical yield, finding the actual yield, discovering which one is the limiting reagent, the limiting reactant, the mass of the excess reactant used, and how much excess reactant is left over. So starting off, like if you're new to stoichiometry and you just like first glance at it, it may look very difficult. But what all it is basically is a lot of math. That's all it is. A lot of stoichiometry mainly is just converting. You're either converting moles to moles, moles to grams, grams to moles, moles to liters, liters to moles, liters to grams, grams to liters. Or it could be in scientific notation. So, the most important thing about stoichiometry is you won't be able to solve a stoichiometry problem until you balance the equation first. If the equation is not balanced, you won't be able to solve any questions. So on this paper, it says, balance the equation in order to solve the following questions. Show your work to receive full credit. So we have iron, sulfuric acid, iron, what is this? Iron 4 sulfate, and hydrogen gas. So we have to balance this first before we can solve the question. So before I even get to the question, I'm gonna solve it first. So let's solve it. So we can set it up like this. So first, write all your elements. Make sure to write the same ones on each side so they're aligned with each other. So I have iron, I have hydrogen, I have sulfur, and I have oxygen. What I did for one side, I'm gonna do the exact same thing for the other side. So I have iron, I have hydrogen, I have sulfur, and I have oxygen. Next thing you need to do, look and see how many each one has. So iron is nothing, if it's nothing directly behind it, it just means it's one. So iron, I have 1. Hydrogen, I have 2. Sulfur is nothing, so the 2 does not go with the sulfur, it only goes with the hydrogen. So I have no number directly behind the sulfur, so it's only 1. Oxygen has a 4, that 4 is only with the oxygen, it is not with the sulfur. So for oxygen, I have 4. Now we go on the other side. If I look at iron, I have a 2. This 2 for right now only goes with the iron. So 2 irons. For H, I have a 2. There's nothing else in front of the H, so it's just 2. Now, let's look at S. S is inside the parentheses, but it's also a 3 outside the parentheses. So basically, just like with algebra, you're distributing. So I'm gonna multiply everything inside the parentheses by the number directly outside the parentheses on the right. So I'm gonna do 3 times S. Remember, if there's no number directly behind it, it just means it's 1. So it's basically just 3 times 1. So I'm gonna have 3 S's. Oxygen has 4, but it's 3 on the outside. So 3 times 4, I'm gonna have 12 oxygens. Now, you're trying to balance it to where all of these will be the equal numbers of each side. So I have 2 iron, so you're trying to look at which ones are different to balance. I have 2 irons on the right, 1 on the left. I have 3 sulfurs on the right and 1 on the left. And I have 12 oxygen on the right and 4 on the left. So let's say I'm gonna start with the sulfur. So let's look at S. If I have 3 over here and 1 over here, what do I need to multiply this S by to give me 3? Well, 3. You can look at it as, okay, what do I need to multiply by? Or you can do, 3 divided by 1 is 3. So I'm gonna put a 3 right here. These are my coefficients. These are my subscripts. So now if I put a 3 right there, that 3 for the coefficient is multiplied by all of this right here. So now 3 times H2 gives me 6 H's. So I'm gonna come down here to my H. I no longer have 2. I'm gonna cross it out and I'm gonna write a 6. 3 times S is basically 3 times 1. So now I'm gonna cross that 1 out. Now I have 3 S's. 3 times O4 gives me 12. So now I'm gonna cross out my 4 and write 12. So now I have 12 oxygens on the left side. So let's look now and see what's different. Okay, I still have 2 irons on the right, 1 on the left. So let's fix that part. So 2 over here, 1 over here. So what do I need to multiply 1 by to get 2? A 2. So I'm gonna put a 2 in front of the Fe. 2 times Fe is 2, so cross out my 1, make it a 2. Now, what's different? The only thing left that's different is I have 6 H's, 6 hydrogens on the left side, and only 2 on the right side. So what can I put in front of this H2 to give me 6? 2 times what is gonna give me 6? 2 times 3. So I'm gonna put a 3 right here. 3 times 2, 6. So I'm gonna cross this out, make it a 6. And if it's nothing directly in front, it just means it's 1. So for this the purpose of this video, I'm gonna put a 1. So now let's look at all my elements at the bottom. For iron, I have 2, 2, that's the same. Hydrogen, I have 6, 6, that's the same. Sulfur, I have 3, 3, that's the same. And oxygen, I have 12, 12. Boom, it's balanced. So that's how you, if you don't know how to balance equations, that is how you balance chemical equations. Now we can actually get to the problem. So the question is, 402.6 grams of iron reacted with 260 grams of sulfuric acid. 3.9 grams of hydrogen gas were produced. What is the actual yield, the theoretical yield, the percent yield, the limiting reagent, the excess reactant, the mass reactant used, mass of excess reactant used, and the mass of excess reactant that remains. So it's multiple things we have to solve for this. So the first thing we need to do is figure out which one is our limiting reagent. All the limiting reagent, if you don't know what stoichiometry, the limiting reagent or the limiting reactant is the reactant that is used up first. So once all of this reactant is used up, you can't make any more products. The excess reactant is whatever's left over on the reactant side. So imagine if you were making like a hamburger and you got the cheese, you got the meat, and you have the buns. Well, if I run out of buns first, I can't make any more cheeseburgers, right? Because I need the bread. So that means in order I can't make any more. In order to make some more, I would have to go buy some more buns. So that's basically what so in that situation, the bread would be the limiting reagent, limiting reactant, because it runs out first. Whichever one runs out first is the limiting reagent, limiting reactant, and whatever's left over is the excess. So, in problems like this where they're asking you to calculate the percent yield, a lot of the times they will give you the actual yield in the problem. So the actual yield is how much is actually produced. So you're looking for something in the problem that has to do with the product side. The theoretical yield is what can be produced in like a perfect reaction. The actual yield is what is actually produced, and the theoretical yield is what could be produced in a perfect reaction. And then the percent yield is kind of like the percent error. So to calculate the percent yield, you'll take the actual yield divided by the theoretical yield. So the first thing you need to do is find the limiting reagent. So it's 2 ways you could do that. But for this purpose, the best way is to solve calculate both the reactants. So I'm gonna calculate iron and I'm gonna calculate sulfuric acid. So first thing you do is set them up like this. So I'm going from grams to grams. So when you go from grams to grams, you're gonna have 4 lines and you're gonna multiply 3 times. So I'm gonna set my lines up. So 1, 2, 3, 4. 1, 2, 3, 4. So for both of these, I'm gonna put my grams, how much I'm starting with for my reactants, on the top line for each one. So in stoichiometry, whatever they give you goes on the first line. Whatever you're looking for goes at the top of the last line. So they gave me 402.6 grams of Fe, which is iron, and then they gave me 260 grams of sulfuric acid, so H2SO4. We're looking for grams of H2. That's what was produced. So on the top of the very last line, I'm gonna put grams of H2 for both of them. So in stoichiometry, it's basically you're crossing out whatever's the like terms. So whatever goes at the top of one line diagonally is going to go at the bottom of the next line. So since I have grams of iron up here, that means diagonally down here, I'm going to have grams of iron. And whenever you have grams of something, you're going to have, in stoichiometry, whenever you have grams of something, you're going to have moles of the same element or compound. So if I got grams of Fe at the bottom, at the top, I'm gonna have moles of Fe. And when you have grams and moles together, the mole is always 1. So let's set the same at the bottom. So I'm gonna have grams of sulfuric acid. So at the top is moles of sulfuric acid, H2SO4. And again, the mole is 1. So again, whatever goes at the top, diagonally goes at the bottom. So if I have moles of Fe right here, that means down here, I'm gonna have moles of Fe. So mole of Fe. Same thing down here, mole of sulfuric acid, H2SO4. Now, again, I told you, if you have grams of something, on the opposite side, you're gonna have moles of the same thing. So if I have grams of H2 at the top, at the bottom is gonna be 1 mole of H2. So down here, 1 mole of H2. And then that means diagonally at the top up here, I'm gonna have moles of H2. Same at the bottom over here, mole of H2. So if you notice, everything is the same diagonally. All right, so it would be the same thing if I were converting liters. Moles and liters, the liters would be 22.4 and the mole would be 1. All right, so wherever you have grams, that's where you have to calculate the molar mass. So the molar mass of Fe, get my periodic table, Fe is 55.845. So wherever I have grams, that's where I'm gonna put my molar mass. So for Fe, it's 55.845. See, now I have grams of H2 at the end, at the top. So H is 1.008. 1.008 times 2 is 2.016. So now let's go to the bottom. I had the same thing, 2.016. So to calculate the molar mass for the bottom for sulfuric acid, if I know H2 is 2.016, S on the periodic table is 32 point, so S is 32.065 and O is 15.999, and it's 4 of them, so times 4. And you add all that up. So I would get 2.016 plus 63.996 plus 32.065, you get 98.077. So that's my molar mass for sulfuric acid, 98.077. Now, the only thing left is mole over mole. That's mole. When you get mole over mole, that's called the mole ratio. That's why it's so important that you balance the equation. So you're gonna use the coefficients in the front to calculate the mole ratio. So I got mole of H2, what's in front of the H2? A 3. So I'm gonna put a 3 right here. What's in front of the H2? A 3. What's in front of Fe? A 2. So I'm gonna put a 2 down here. What's in front of H2SO4? A 3. So now we need to calculate both of these equations to figure out which one is smaller. Whichever one is smaller is going to be the limiting reagent, limiting reactant, and whichever one is bigger is the excess reactant. All right, so you can actually put all of this in the calculator together. So I'm going to put 402.6 times 1 divided by 55.845 times 3 divided by 2 times 2.016, and you're going to get 21.80. So for this one, for iron, (21.80 grams). That's how much was used up. Now let's do sulfuric acid. 260 times 1 divided by 98.077 times 3 divided by 3 times 2.016. You get 5.34. So this one is 21.80 grams. This one is 5.34 grams. So again, whichever one is the smaller one is your limiting reagent. So 21 and 5, the 5 is smaller. So the sulfuric acid is our limiting reagent, limiting reactant. So when it says limiting reactant, element or compound, I would write H2SO4. Excess reactant or compound, I would write iron. So the iron was my excess. All right, so where it says theoretical yield and percent yield and actual yield. So remember, I told you, whenever you're calculating percent yield, they will give you the actual yield a lot in the problem. So it says 3.9 grams of H2 were produced. So that's how much was actually produced. So the 3.9 is my actual yield. The theoretical yield is what could have been produced in a perfect reaction. So what could have been produced was the 5.34. So that's my theoretical yield. So 5.34. Now to get my percent yield, all I do is calculate the actual yield divided by the theoretical yield. So 3.9 divided by 5.34 times 100, you get 73.03%. 73.03%. So that's my percent yield. Now, the only thing I need left to calculate is the mass of excess reactant used and the mass of excess reactant that remains. So for this one, I'm only using the reactant side. So I have to convert my limiting reagent to my excess reagent. So if I know my limiting reagent was the 5.34, well, my limiting reagent, the sulfuric acid, so that's what I'm gonna start with. Now, to find the mass of the excess reactant used, you're only using the reactant side. So the limiting reagent was the 260 of sulfuric acid. So I'm gonna set that up, 260 grams of sulfuric acid. I'm only using the reactant side. So again, I'm going from grams to grams. I'm solving for these two. So I'm going from the limiting reagent to the excess reagent. So I'm gonna have 4 lines. So what you do on the top of one line goes on the bottom of the next line. So if I have grams of SO4 up here, that means down here I'm gonna have grams of H2SO4, which means at the top I'm gonna have 1 mole of H2SO4, and I'm looking for grams of Fe because that's my excess reactant. So at the bottom I'm gonna have 1 mole of Fe. So that means diagonally right here at the top I'm gonna have mole of Fe. And then diagonally at the bottom I'm gonna have mole of H2SO4. So remember, wherever you have grams, that's the molar mass. We already calculated the molar mass up here, so I don't have to calculate it again. It's 98, that's where you use the periodic table and calculate the atomic mass, add them all up to get the molar mass. Fe, we already did that one too. It's 55.845. And then mole over mole is when I use the coefficients. What's in front of the Fe? A 2. What's in front of H2SO4? A 3. So now, just plug it all into the calculator. So 260 was my limited reactant, times 1 divided by 98.077 times 2 divided by 3 times 55.845, you get 98.69. So I'll round that to 98.70 basically. So that's how much excess reactant was used before the reaction stopped. Now it wants to know the mass of the excess reactant that remains. So if I started with 402.6 grams of Fe, and I just used 98.7 grams, just divide the two numbers. That turns to 16, so that'll be 9, that'll turn to 11, 3, so 303.9 grams is how much that remains. Let's check my math real quick. 402.6 minus 98.7. Yep, 303.9. So for this question, the actual yield was 3.9. Remember, the actual yield, when you're looking for a percent yield, they'll give you more than likely the percent yield, the actual yield in the problem. It has to do with the product side. H2 is on the product side. It says 3.9 grams of H2 were produced, so that was my actual yield. Theoretical yield is whatever the limiting reagent is, when you solve it, whichever one is the smaller one, that's your theoretical yield, what could be produced in a perfect reaction, basically. That's why it's called theoretical. So to get the actual percent, you take the actual yield divided by the theoretical yield times 100, and that's going to give you the percent yield. So 3.9 divided by 5.34 gave me 73.03. The limiting reagent was the sulfuric acid, the H2SO4. The excess reactant was the iron, the Fe. To calculate the mass of the excess reactant, I convert the limiting reactant to the excess reactant, and I got 98.70. And then to find out how much is used up, is how much remains, you take what you use minus how much you started with. We started with 402.6. We used 98.7. So subtract the two, you get 303.9 grams. And that is how you solve for percent yield, actual yield, theoretical yield. Find the limiting reagent, limiting reactant, the mass of it, how much excess reactant you use, and how to find what's left over. If you have, check out more of my videos. Subscribe to the channel, like and comment. More videos coming soon. Trey T out. Peace.